Welcome back to trigonometry. You remember last time we were talking about sine, cosine, and tangent, and I listed some properties, and I'd like to show you why this is true. These are not proofs, but these are called heuristics. These are believable examples. And what a proof is in mathematics, we're going to talk about a little later today. Remember, if we have our coordinate grid, so first off, just by using the definition, now we're going to not use the unit circle right now. Let's look at the point 1, 2, 3, 4, and 1, 2, 3. So here's some point right here. This is 4 on the x-axis and 3 on the y-axis. Everybody knows how to do this. Okay, so what happens if we draw a radial line out here, like this? And here we have a triangle. We have a right triangle, and here's some angle alpha. So first, this is 4, this is 3. We know from the Pythagorean theorem that this r is equal to 4 squared plus 3 squared square root. This is the square root of 16 plus 9. This is the square root of 25, so this is 5. And I picked 4 and 3 on purpose. They're called Pythagorean triples. It's just easy to work with. That's where those numbers came from. Let me clean this up a little bit. Okay. So the first thing that you definitely want to be able to do is tell me what is the sine of alpha. And this is straight from the definition. The sine of alpha is the y divided by the radius. So this is going to be 3/5. Similarly, the cosine of alpha is going to be 4 divided by 5. And this is just the definition of what sine and cosine are. And lastly, what is the tangent of alpha? Well, this is the same as the sine of alpha divided by the cosine of alpha. However, there's an easier way to remember it. The tangent of alpha is simply y divided by x, which you remember from algebra is rise divided by run. In this case, the rise is 3, the run is 4, and this is 3/4. So that's the first thing you need to be able to calculate. Remember, I talked last time about some properties of sine and cosine, and it's really somewhat important to know these. And remember definitions. We say f of x, a function in x, is even if f of minus x equals f of x. That is, if you have a negative sign inside it, it just kills it off. And I claimed that cosine of minus x is equal to cosine x. Now, this isn't a proof. Mathematical proofs are more involved, but you can kind of see that this is true. Let's look at this. Let's look at some properties of cosine. Let's take this down here, this point right here, which, this isn't quite right. Let's go 1, 2, 3. So let's go to 4 and minus 3. So now here, we'll do this. Here's this. This is still 4 across this way. Now the y is going down. This is minus 3. The radius is always going to be positive. It's 4 squared plus minus 3 squared square root. It's still 5. And now what is this angle? Well, we know as we're going up, the angles are positive. As we go down, the angles are negative. If we want, we can write this as minus alpha, this. So what is the cosine? We already know that the cosine of alpha, we just figured that out, was this 4, the length across x, divided by the radius 5, which is 4/5. And now, what is the cosine of minus alpha? Well, the cosine of minus alpha, if we go down here, it's still this 4. And let me be very clear where this 4 is coming from. We're here. This is 1, 2, 3, 4. It's 4 across, and we're still dividing it by this 5. So this is, in fact, still 4/5. So what do we have here? Instead of alpha, we could place an x. So this means that for this particular example, cosine x equals cosine minus x. you may be convinced that now cosine is an even function following this dictum, but this isn't a mathematical proof. You cannot prove anything by just showing one instance with one picture. However, it should lend some credence. You can't really prove this in any way that I can think of until about Cal 2. You need Taylor series to prove this. Now, you remember that I claimed that sine of x is odd. First, let me define an odd function. F of x is odd if f of minus x equals minus f of x. That is, the negative sign gets pulled out. For the same example, let's see what we got. Now we know, we already did this, the sine of this alpha is going to be 3 divided by 5. So we know that sine of alpha is 3 divided by 5. What is the sine of minus alpha? Well, so it's going to be whatever the y component is, which in this case is minus 3, divided by the radius, which is 5, so this is minus 3/5. You'll notice that minus 3/5 is exactly equal to minus sine alpha. And this is exactly what we needed to show for being odd. These things really come in handy in computations, and you're going to use this. There are some integrals, all of you are probably going to calculus. There are some integrals that are really going to be hard to solve, but if you can use the even or odd properties of your trigonometric functions, you can figure them out really easily, and this will make you happy. Trust me. Okay, so this is what I would like you to think about now. What's tangent? Is the tangent function, and I'm going to write it in x because it's a function in x, we usually do, is this even or odd? And I was just thinking, odd is probably what you're thinking about what I'm wearing, but I did want to dress up for you today because it's a special day today. You had your first almost mathematical proof. We are going to do some proofs today, incidentally. So, well, let's see. If it is even, suppose that it is even. That means that the tangent of minus x has to equal tangent x. Actually, you know what? This is something like a proof right here. In mathematics, proofs have to be very tight and well constructed, but this is starting to get to the flavor of this. Suppose that tangent x is even. We have to prove that this is true. Well, we know that tangent x, and we might as well make this nice and colorful. We know that tangent x is equal to sine x over cosine x. This is simply a definition. That means that tangent of minus x is equal to sine minus x divided by cosine minus x. What do we know about sine and cosine? The cosine will kill off this minus. The sine, the x comes through, or the minus sign comes through. So this tangent of minus x is equal to minus sine x. The cosine kills that negative sign off, just cosine x. This is equal to minus tangent x. So it is in fact not even. So we showed that this isn't true. What we just showed was that tangent of minus x is equal to minus tangent x. So tangent is odd. And once again, this will help you figure out things later down the line. Pretty much everything I just showed you up here you really need to know. Sorry about that. A lot of memorization in Trig. We're going to take a quick break because we go in 9 minutes to make the uploads to YouTube easier. But I would like to leave you very briefly with what we talked about last time, and that is for any x in radians, sine x squared plus cosine x squared equals 1, and I actually proved that. We'll be back in a minute.